All right, so our next presenters are Sarah Hirsch and Dr. Ray Weil. Sarah is a PhD student working with Dr. Weil. She's been researching cover crop systems and deep nitrogen uptake since 2014. Dr. Weil is a professor at the University of Maryland and has over 30 years of experience researching sustainable soil and crop management, cover crops, soil fertility, and nitrogen cycling. His lab leads research to make cover crops benefit farmers and the environment in the Mid-Atlantic region. So today their presentation is titled Go Deep, Go Early, Effective Cover Cropping for Nitrogen Capture. So I'd like to turn over the screen now and feel free to get started.
Well, hello everybody out there in webinar land. Thanks a lot for showing up and listening. I hope this will be useful for you. I think we've got some exciting new data. It's been a lot of fun doing the research over the last few years, and I'm accompanied by a terrific PhD candidate who will be out in the market to be a scientist very shortly, Sarah Hirsch. And she's responsible, along with a small army of students, for getting most of this done. Go to the, if I can, there we go. So let's, wanted to start out just by acknowledging where we are here in Maryland. I do quite a bit of speaking these days. Soil health is kind of a big topic around the country, and I had the opportunity to speak at the National Notill Conference, at Notill on the Plain, at farmers conferences around the country, especially in the Corn Belt and elsewhere. And I have to tell you, Maryland looks pretty good compared to everywhere else. So a shout out to the farmers and the nutrient management folks and all the people that have been working, MDA and everybody else in Maryland, who has really put us pretty much ahead of the game in a lot of ways. For example, just focusing on nitrogen, we use a lot less nitrogen than we used to. Our recommendations are come down. This is not true everywhere. There are a lot of places in the country that are still recommending what we recommended 15, 20 years ago or longer. That is, they're throwing their nitrogen down the drain and to the Gulf of Mexico. Split applications of nitrogen is pretty commonplace. It's what everybody does in Maryland, but it's a pretty unusual practice in much of the Corn Belt. Maybe 5 or 10% of the farmers are doing it, and they're considered to be real innovators. I think almost everybody does it here. Fall nitrogen application is totally unheard of for corn in Maryland, but that's still something that you see done. And I think a lot of our farmers are starting to think about going to some of the computer programs that can aid in fine-tuning nitrogen management. So we can see this actually in the trends of what's actually been happening. I've worked with the nutrient management folks to get some data and graph about a 22-year period of data from 92 to 2014 was the data I could find. And it shows that Maryland corn yield average has been going up. It's pretty close to the average in the Corn Belt and going up at about the same rate. Lots of variability, and of course some counties have much higher yields than others. But the interesting thing is while the yields are going up pretty much like the rest of the country, nitrogen use in Maryland, now this isn't application to corn, this is nitrogen use in the state of Maryland, but most of that goes on corn, has been going down on a pretty dramatic trend. So we've succeeded in uncoupling yields with nitrogen, and that's something that they're just beginning to think about in other parts of the country. So I think we have a lot to be proud of, but as you can see, when you look around and you measure the groundwater and you even look at our cropping systems, we still have a long way to go. And I imagine some of you have probably seen a scene like this. Now, in full disclosure, I've increased the contrast in this photograph so that the stripes show up a little bit better. But this is a cover crop. I think it's rye, it could be barley. But you see this quite often around the state, these stripes of green going across the field. And when I first saw them, I was wondering about them. They're 5 feet apart. And this turns out that this is, quite a few growers will side-dress their nitrogen every second row instead of every row. And so the stripes are 5 feet apart. But what this is telling us is that there's nitrogen left over from that fertilizer application back in June when the corn was knee-high. In fact, I've measured the nitrogen in the green strips compared to the strips in between, and I'm afraid to tell you that in a number of cases, I found more than half. In other words, the difference between the green and the less green strips contains more than half of the nitrogen that was applied. So that must have been left over. Pure speculation here, but I think part of the issue might be the modern corn hybrids are not only higher yielding, as you know, we're now talking about shooting for 300 and plus bushels. And part of that high yield comes from these aggressive deep roots, which makes the corn a little more drought resistant. But it's possible that with this very steep angle on the roots, when we come in and Sidedress and put the fertilizer around there, it may just be that the corn roots are diving deep and really don't see a lot of it because they're not as horizontally spread as corn roots used to be. Sarah, you want to tell them a little bit about the project that we've had going for the last 3-4 years?
Sure. So our idea was that all of this leftover nitrogen that's being left over applied to the previous year's corn could be a benefit for farmers by allowing them to apply less nitrogen fertilizer if it could be captured by cover crops. And this could also reduce the nitrogen inputs into the bay. So our kind of slogan for this research project is deep-rooted cover crops, adding nutrients to your bottom line, not to the bay.
Well, one of the things that got us thinking about this deep nitrogen was a number of experiences. First of all, whenever we plant cover crops early in the fall, if you plant them early enough, especially on dairy farms that have a history of manure or where there's poultry manure applied, but even other farms, when we plant cover crops really early, it's not unusual for us to get 200 or 300 pounds of nitrogen in the foliage of the cover crop that fall. Wow. That's telling us there's a lot of loose nitrogen floating around in that soil someplace that's plant available and is likely to be leached. I mean, was shocking when I first started measuring those. This is an experiment up here in Beltsville in central Maryland on a dairy farm, comparing the treatments on the right and on the left. There's a cover crop and no cover crop. The cover crop in this case was mostly radish. There was also weeds that we measured. And different plots had different amounts of nitrogen taken up. So the horizontal axis, if I can grab the pointer here and then pull it down here. The horizontal axis is the amount of nitrogen in the plant biomass. And the vertical axis is how much nitrogen we found in the top 1 meter of soil. So we assume that if the plant's pulling it out of the soil, we ought to see less in the soil. And you do see less, but not that much less. Let's see what that looks like. So the highest nitrogen uptake in this experiment was about 150 pounds of nitrogen per acre. But when we looked at the top meter, that's on a little more than 3 feet of soil, we only found about 40 pounds of nitrogen missing. So that raised the question, what about the other 110 pounds of nitrogen? It doesn't seem to be coming, we can't see it missing from the top meter. And one possibility is maybe it's deeper than a meter. Maybe it's not deeper than 3 feet. Maybe it's 4 feet, 5 feet, 6 feet. So we figured we're going to have to put a little elbow grease into this. Sarah, want to tell us what you ended up doing as a result?
So the first part of this experiment that we did was that we just wanted to survey how much nitrogen was left in after growing a crop, so like after a corn or soybean crop, how much nitrogen was left from 0 to 7 feet deep. And so we looked at this on many farms across Maryland and Pennsylvania where we took soil cores in a transect across the field, and you can see our sampling scheme on this diagram here. Each of the red X's is where we would have taken a soil core. So we had cores at 5 points across the field, and at each of those points we took 2 deep soil cores down to 7 feet, and we did this over 3 years for a total of 25 cornfields and 4 soybean fields. And so pretty early on in this experiment, we found that what we had initially planned to do was use the tractor-mounted Giddings probe, which would have been easier to get the cores, but that didn't work to go down to 7 feet. We couldn't get much past 3 feet with those because even when we anchored the tractor in, it was lifting the tractor off the ground and the poles were bending. So we went back to a technique called the Viemeyer probe, which was designed in the 1920s. And it's just a long metal pole that we hand hammer into the ground using a drop hammer, and then we jack it out of the ground and we empty it onto the trowel using just a stick and banging the soil out. And then we so we spread out the soil to 7 feet as it was in the ground, and then we divide it up and measure the amount of nitrate and ammonium that would have been plant available in each of those 15 centimeter increments. So we looked at 14 segments in each of those cores 0 to 7 feet. And this map is showing the sites that we sampled in 2014. So you can see that they're on the eastern shore of Maryland and other parts of Maryland, western Maryland, and into south central Pennsylvania. And these are the results that we had from our survey in 2014. In the on average, this is showing divided up between the Piedmont farms, which are those farms in western Maryland and Pennsylvania, and then the eastern shore Maryland farms. But on both of these soil types, we found between 300 and 350 pounds of nitrogen per acre total, and that could be divided up between about 75 pounds in the top foot of soil, so from the surface down to 1 foot deep, and then we found about 100 pounds of nitrogen per acre from each 2 foot increment below that. So about 100 pounds from 1 to 3 feet deep, about 100 pounds from 3 to 5 feet deep, and about 100 pounds from 5 to 7 feet deep. And this is the inorganic nitrate and ammonium that would have been plant available.
So I should just add to that that there was a lot of variability, of course, in terms of the total amount of nitrogen we found and whether it was high or deep in the profile. But even the relatively infertile sandy sites generally had about 200 pounds, or I think the lowest was around 150 pounds of nitrogen under it. And some sites were just off the charts. There was one site in Pennsylvania where they did not have mandatory nutrient management. And this guy just loved putting on manure, and he had about 800 pounds of ammonia and nitrate under every acre of his farmland. And we found a fair number of them with 400 or 500 pounds here in Maryland as well. Now, one of the interesting things, all the first 2 years we're looking at cornfields. We were looking at this. We were thinking, well, this is leftover fertilizer applied to corn, and some of it, that is some of the problem. But Jimmy Lewis, as some of you may know, is an extension agent and a farmer himself over on the Eastern Shore, suggested that we also should look at soybean fields. And he had a good idea because, of course, soybeans, first of all, they're in rotation with the corn. They're in the same fields, but they're a very high nitrogen environment. They produce high nitrogen residues that decompose quickly. They fix a lot of nitrogen. And even though most of that's taken off with the beans, we thought we'd have a look. And we did this in 4 pairs where we had paired corn and soybean fields side by side on the same soils. We did transects through both of these pairs on 4, 2 on the eastern shore and 2 on the western shore. And there wasn't any difference in ammonia, and that ammonia is probably, it's in similar amounts as the nitrate, by the way, but it's probably entrained. It's probably held by the cation exchange capacity and not moving through very fast. But the nitrate, on the other hand, each of these sites, so this was a consistent, significant trend. The nitrate in the soybean fields was significantly higher than in the corn field. So one thing we might start thinking about is maybe focusing our nutrient management and cover crop capture practices more on the soybean than on the corn, or at least also on the soybeans. That seems to be an important thing that we may have been missing. So I have a little, we came up with basically a hypothesis, since we felt that there was this large pool of nitrogen that really hadn't been considered to be that large. We found that indeed it was there, so we started thinking about how can we manage this instead of have it be an environmental problem. Let's turn it into a resource for farms. And so our hypothesis was that you had to get cover crops in early to take care of the problem. So this is my hypothetical depiction of kind of a standard cover cropping practice in Maryland. These are not real data, but this is showing a pool of nitrogen throughout the top 2 meters of soil. harvesting corn, say, and sometime in mid to early October, planting rye. So we got these little rye plants out there, and I'm being pretty generous with my nitrogen estimates. Those little plants you can't really measure the nitrogen in October, but say by Thanksgiving, maybe you'll have 5 to 10 pounds of nitrogen in the foliage. Take it up. Pretty shallow root system at that point. In the meantime, of course, the deeper nitrogen is moving down, moving down, moving down. So during the winter, where a lot of the leaching takes place, by the time we start getting green up in March, a lot of this nitrogen that was deep is now being lost completely from the system. The rye is finally starting to grow if we don't kill it in March, which many farmers do. But assuming we let it grow until April and mid-April, maybe if we're lucky, we'll take up 40 or 50 pounds of nitrogen with that. Most of that will have come from near the surface. We'll never have gotten this large pool of nitrogen. There's my little pointer. A large pool of nitrogen that's down below. By this time, that's gone. So as an alternative concept, we thought, well, we need to get a more aggressive cover crop, and we need to get it in earlier so we can get roots down where the nitrogen is before it's lost from the system. So let's say we change that scenario, and through some kind of magic like aerial seeding or lots of other techniques we'll talk about, we get that cover crop planted in early September instead of in early October, a month earlier. Now, and we choose the most aggressive cover crops available. So even more aggressive than rye, if you get it planted early, is radish. There's just about nothing that will grow roots as fast and take up nitrogen as fast as radish in the fall if you plant it early. So we can easily measure 25, 30 pounds of nitrogen by the end of September and 100 and some by the end of October. By Thanksgiving, it's not at all unusual with that early planted to get 200, sometimes 300 pounds of nitrogen in the foliage and also in that big tuber. And then you'll know it winter kills. When we get some really cold weather this year, it winter killed in early December. And it decomposes very quickly. In fact, it doesn't even have to decompose. A lot of that nitrogen is in the nitrate form. We've measured that in the tuber and in the tissue. So the nitrogen gets released early, and that could theoretically be a problem. But we really don't think it is, except on maybe the sandiest soils, possibly following soybeans, where there's no immobilization. So we've got this dead radish, and then the situation in spring is that nitrogen that was deep has now been sucked up, brought to the surface, and it's being released on the surface. It's starting to move down a little bit, but we're now planting, let's see if I can find my little arrow here. We're now planting into a nitrogen-rich environment. We can cut back on our fertilizer. We certainly don't have to apply any extra fertilizer. If we go back and look at the situation here for rye, when we're planting in here, the rye has depleted the nitrogen in the surface soil, and the corn is going to be nitrogen deficient. We know it, so we're going to have to put on extra nitrogen to make up for the fact that the rye captured some nitrogen. I'm not sure this is helping us. We're putting more nitrogen into the system than we would have otherwise because we've got this rye that's captured nitrogen mostly from the surface. So it really makes a difference where that nitrogen is. Location's important in this game. So we'd like to capture that deep nitrogen, bring it to the surface where we can use it. Now, is this just fairy tales, or does it actually reflect reality? In order to find out, we got Sarah to work again in the field, this time using some expensive tracers. This stuff is the most expensive fertilizer you're ever going to buy. It's potassium nitrate, which is expensive to begin with, but this stuff is 99%. The nitrogen in it is N15. That's a naturally occurring, non-radioactive, non-toxic isotope that weighs exactly 1 neutron more. Now, if you have a mass spectrophotometer, you can tell N14, which is the normal nitrogen, from N15. We send our samples to Cornell University. Sarah, do you want to tell us what you did with this?
Sure. So we buried some of this tracer nitrogen at different depths. And then on top of that, we planted different cover crops during different sampling dates. So I'll tell you a little bit about our process of burying it. So we augered down to our desired depth, and we put a PVC pipe into that hole, and then we poured a liquid solution of potassium nitrate of that tracer nitrogen down into the hole. And then after we got that tracer to the depth that we wanted, we backfilled with about 1 foot of soil, and then most of the hole we backfilled with a bentonite sand mix, and that prevented the roots from preferentially growing down the hole that we had augured. And then on the surface layer, we replaced the topsoil that we had removed. And so then we had our tracer at the depth that we wanted it, and we planted the cover crops on top of that, and we ran this for 2 years now. In the first year, we buried it at either 1 meter or 2 meters deep, and in the second year at 60 centimeters, 120 centimeters, or 180 centimeters. And then we planted cover crops on top of those, that buried tracer, either at an early planting date, which was the beginning of September, or a late planting date, which was 1 month later in early October. And we looked at different cover crop species. We planted forage radish by itself and rye by itself. And then we did a 2-way mix of the radish and rye. And then we did a 3-way mix, which included the radish, rye, and a crimson clover. And we wanted to add the crimson clover to see what effect having a legume in the mix would have on the radish and the rye performance.
I think there was a little trepidation with the MDA when they allowed legumes into the mix, and they limited where that could be with the idea that maybe the legumes would somehow reduce the nitrogen capture of the rye and the radish. Rest assured, we didn't find that. Here's some of the results.
So, these are some of the soil results. So the next slide we'll talk about when we found the cover crop was taken up in the tissues. But this was a little side project that we did just to see how deep the nitrate was moving and leaching after we had placed it. So we placed the nitrate, the tracer nitrogen, at 1 meter in early September, and then 3 months later, we went back and took soil cores right beside that point where we buried it, and we found that it had leached down about 1 foot in those 3 months. And then we went back again the following spring in May to take more soil cores right beside where we buried it, and we didn't find any evidence of that tracer all the way down to 2 meters. So we believe that it had leached out of the system by the spring, which just emphasizes, again, the importance of capturing that nitrogen in the fall before it leaches out of the system.
So here's, and you can see another picture. Actually, that's Nate Richards. Some of you may know him, recognize him, extension agent over in Kent County. Maybe you're listening. If you are, hi, Nate. So the data on the right shows the atom percentage of N15 to N14. And in nature, there's a little bit of it. It's around 0.37 something. That's this black line. And so where we did not apply any tracer, none of the cover crops showed any change. This is the first time I had used this method like this for tracing. It's incredibly sensitive and precise. So I was very, very impressed with doing this. It was definitely worth the cost. Where we placed that potassium nitrate at 2 feet deep. Now we placed it in the soil at the time when the crop is finished taking up its nitrogen, when it's starting to senesce. So that would have been late August, early September. I think you're aware that crops stop taking up nitrogen often 4, 5, 6 weeks before we're ready to harvest them. Where we placed it 2 feet, you can see that, let me get that little thing, that there was a very strong signal, lots of nitrogen taken up, especially by the radish. It was definitely a stronger signal than the rye. The clover didn't find anything. At 4 feet, this is out of order, I apologize, the one on the left, we still got a very significant signal, obviously less, but the radish was able to get down there pretty well, and there was even a little bit taken up by the rye from 4 feet deep. And at 6 feet, you have to look a little hard to see that, but we analyzed the statistics, and that radish was a significant, there were some roots down there, didn't get a lot, but the roots did get down to 6 feet deep by the time, in order to get that nitrogen before. Of course, by that time, the nitrogen may have been more than 6 feet. It was probably 7 or 8 feet deep because it was moving down as well. It's kind of a moving target. If we planted later, this is October 1st versus September 1st, you can see that the only nitrogen we could get with any of the cover crops was the shallow stuff. The deep stuff was beyond us. And so that pretty much confirms the picture that we had in our mind of if we don't get it in fall, we're not going to get it because it's going to be gone by spring. Just to review a little bit of older data from a publication we did in 2009, I think it was. So we found similar results. This was on a very sandy soil at Beltsville, where we could see pretty distinct bulges of nitrogen from fertilizer applied that year and the previous year. These are two different types of radish. This was back when we were developing the radish cover crop. And this is the plots without any cover crops. So you can see that nitrogen moving down. And in late October, it was already pretty much cleaned up all the way down to 6 feet deep. So this is something that we've seen previously as well. Sarah?
Yep, so these are some results from some of our on-farm trials. In addition to the isotope work, we planted cover crop trials on a lot of the same farms that we had done the transects on. And these, we had replicated plots of radish, some kind of cereal grass, so triticale or rye usually, and then a mix of radish, cereal grass, and clover, and then a no cover crop control plot. And these are just two examples that we put here. One was showing an early planting date, and you can see that this farm up in Lancaster, PA, was both the radish and the cereal grass and the mixed treatments were all pulling up upwards of 150 pounds of nitrogen per acre. Whereas a farm that did not get the cover crops planted until early October, which is more of the normal practice, those cover crops, the radish and the cereal grass, were only taking up about 5 pounds of nitrogen per acre. So just huge differences in the amount of nitrogen that the cover crops are taking up.
So this is not a small point. The date of planting in September, that month of September, is really critical. A couple of weeks makes a huge difference, and we're looking here at a whole month's difference. Just another visual here. Radishes planted about a month apart, and photos taken. These are planted right next to each other in the same field, taken at the end of October. So that little radish is just not going to be able to do very much, either beneficial in terms of biodrilling or weed control, and it won't take up much nitrogen, but the nitrogen is not quite as bad as you might envision from the size of the radish. So we do have some data from earlier studies that I haven't published yet. That's something I've got to remind myself to do, get this data out there. So this was some earlier work where we planted the radish every week, going from August 20th to about October 1st. And of course, the ideal planting would be to get it in before about the 10th of September. And you know, after the first week of September, the biomass starts going down. This is just the shoot biomass. We could also talk about the root, which is significant as well. However, those younger plants are higher in nitrogen. The concentration is higher, and it goes pretty much up here. So at least through the month of September, we were able to maintain a pretty good nitrogen uptake. In this case, about 125 kilograms per hectare. After that, it dropped off to next to nothing very quickly. Another point that's of increasing interest as farmers are becoming interested in multi-species cover crops, mixes, some of them call them cocktails. There are a lot of advantages, I think, to having mixes. I don't know if you need 17 or 18 species, but 3 or 4 species can be pretty useful. One point I'd like to make that this data shows quite clearly, this is from this fall, is that the kind of cover crop you get is not just dependent on the seeds you plant. The seeds you plant is one thing, but when you plant it and into what kind of soil is another. So this is a mixture with 3 pounds of radish, 22 pounds of triticale, and 5 pounds of crimson clover per acre. It's all the same seed. If we plant it early, and again, this is in the first couple of weeks of September, we get about 87 to 90% radish when we measure the biomass. and very little of anything else. The later we plant it, the less the radish does, less competitive, the less cover crop we have too, but proportionally the radish goes down 66 down to 45%. If we look at the and you can see this in the picture where the main thing that's happening is these big radish roots, which are going to alleviate compaction. If you want that to happen, you're going to have to plant early. And the other thing that happens, of course, is you're giving weeds more of an opportunity. These are the grassy weeds that were harvested. So you can see the proportions change pretty dramatically without changing the seeds. And the total amount of biomass produced goes down, and this is just the weeds that were on the control plots. So those cover crops were planted so that we could follow the nitrogen leaching, and we now have lysimeters out in those plots, but of course don't have the data yet. This is some data from last year on a commercial farm on the Eastern Shore in Kent County. And we had similar treatments. We had no cover, we had rye by itself, radish by itself, and then we had this three-way mix, which was planted on 2 dates. Actually, they were planted only about 10 days apart, and there wasn't much rain, so there wasn't a whole lot of difference between the 2 dates. These were on large plots, more than an acre each, using large-scale equipment on a high-yield environment, but a very careful nutrient management environment, and not one with much of a history of manure on it. So this is not a high nitrogen environment. We installed 45 of these lysimeters, which are essentially a tube with a ceramic tip at the end, which allows water to be drawn in if there's a vacuum. One of the tubes goes all the way down to the bottom. You put a vacuum on a short tube and seal it off so that it stays under a vacuum for a number of hours, and that slowly pulls water through that. I think I can get this to animate. Yeah, it slowly pours water, from the larger pores in the soil, which are the pores that are holding water loosely, and that's the water that's normally leaching. So we're catching some of that leaching water, and we installed these between 3 and 4 feet deep. So they're basically below the root zone. The water that it's pulling up is pretty much what's on the way to the bay. This is what it looked like in the field. Had a bunch of free labor from our capstone student team, undergraduates out here. And they came out every second week during February, March, and April to put on the vacuum and collect samples. So we did this. We have it sealed up here. You can see it's a nice no-till field. Here's the data. Pretty surprising. Should make all you nutrient management folks out there feel pretty good. All you flush taxpayers that are paying for this should make you feel reasonably good. Surprisingly, it didn't matter which cover crop system we were talking about. All the greens and the light yellow are all cover crops. Cereal, the mix, and the radish, all right close together. The no cover crop with just some weeds, and you can see there were a few weeds out there, was always much higher, 5 to 6 times as high in nitrate. Now this is nitrate, not nitrate nitrogen. That's just the way I graphed it. So the drinking water standard would be just about up here, a little over 40. But you can see there was a pretty good ability of all these cover crops, even the radish, which was long dead. The radish had died in December, and this is data from February and March and April, all the way through the middle of April. We had really pulled that nitrate down on a fairly sandy soil. So we were pretty pleased to see that. It wasn't the first time we've seen that. I think this is typical. This is a few years earlier on a dairy farm soil in Beltsville. Again, March and April samples. The 3 blue lines are the lysimeters in the no cover crop plots, and the 3 red lines are the lysimeters in the radish plots. In the radish, there's 1 radish that didn't die, but almost all the radishes died. So it's still pretty effective in cleaning up that nitrogen for a number of reasons. First of all, it's brought it to the surface, and secondly, it provides a lot of carbon and grows a lot of bacteria, which immobilize a lot of that nitrogen. Sarah, you want to talk about what farmers can do? I hope we've convinced you that it's really critical and valuable to get cover crops in early. Don't kind of wait until you're all done with everything else and then throw a little rye seed out and get your payment. You really want to get in there. You need to make some changes in your farming system with the aim of being able to get a cover crop in. Preferably, you should be shooting for Labor Day. So maybe Sarah had some experience with some of these.
So some methods that we just put a list together, and I'm sure you all can come up with other ways too, but some methods that we thought was to plant after earlier harvested crops. So a lot of farmers are getting a successful big cover crop in after corn silage or potatoes. There's a lot of new short season corn varieties that have been developed, especially in the past few years, that are yield about as much as the normal corn varieties. And then another technique that some farmers are having success doing is planting cover crops in July after wheat and skipping the second soybean crop. So did you want to?
Yeah, I want to mention that. I know that seems like a stretch to give up soybean crop to plant a cover crop for two reasons. First of all, the soybean crop might make you money, might not, but it's going to cost you money too. But let's say it makes you money, you're going to have to find some payment. Well, and this is sort of anecdotal data, except I've seen the books, including some farmers in Maryland. There are farmers that are putting in these really great multi-species, early planted cover crops, and you're getting tremendous biomass, tremendous nitrogen fixation, tremendous cleanup of the profile, weed control, improved infiltration, all the benefits of cover crops on steroids. And I was talking to a farmer just the other day who said he got 50 bushels extra corn the next year. I'm not vouching for that or not, but how many bushels does it take to be worth the profit? That's pure profit. To be worth giving up the soybean. I know nobody's going to do that on all their fields, but it wouldn't hurt to clean some of that ammonia and that nitrogen out of that 7-foot profile once in a while. Maybe every 5th year or something like that, you could go for this. I'm also trying to encourage Corn Belt farmers who rarely plant any small grains at all to think about putting that in their rotation once in a while, largely for the purpose of improving their soil with that real nice cover crop planting window. Now, I don't think you're going to be able to get any subsidy if you plant in July. I don't think the program will cover that, so that's something we should really have a conversation about because I think this would be a highly beneficial practice. But of course, some of the other things include aerial seeding, which works very well. It's pretty economical. I think we can do some improvements to that, both on the equipment side and seeding side. One of the improvements that we do have a little bit of data on, maybe Sarah would like to talk about the irrigation.
Sure, yeah, we have a slide coming up that'll show our data on that, but we found that if you aerial seed, if you have the equipment to irrigate, if you could irrigate 1 or 2 times after aerial seeding, that'll really help with the seed to soil contact and help the cover crops to come up both earlier and better in a better stand. And then another method that we're doing a little bit of experimentation with is starter nitrogen, which seems counterintuitive since we're applying the cover crops to take up nitrogen out of the soil profile. It doesn't seem right to be adding nitrogen to the cover crops, but we're finding and we think that if we apply just like 10 pounds per acre of nitrogen to the cover crop, then that will allow the cover crop to grow so much better and to get the roots down deeper, so it'll take up potentially up to maybe 50 pounds of nitrogen more than it would otherwise. So it would be a net addition of nitrogen that it's taking up. And then some other methods are interseeding, and that can be done both during nitrogen sidedress time in June and later on in the season during the crop senescence. And we have some photos to show that. So this was a photo of the stand of a radish and rye cover crop that was aerial seeded. So you can see it's a little bit patchy in areas, but in general, the radish is really good at kind of spreading out and growing bigger if it has more room. So it turns out pretty good, and where there's not as high density of seeds, then the radishes will grow bigger. And here's some equipment that could be used to interseed during the crop senescence. This is showing drop-down nozzles on a highboy that are going through a senescing soybean field. And this one is showing a cover crop being interseeded at the same time that sidedress nitrogen is being applied earlier on in the season in June. So, and then we have a photo of the interseeded cover crop, what it looks like.
So this photo, this interseeded cover crop in the photo was broadcast, not drilled. So the this interceding drill has been developed by Penn State University, and it's being commercialized. And it drills 3 narrow rows between every corn row. This does not work with soybeans. It's too dark down there. They won't survive. But with corn, there are a number of species of cover crops that do pretty well and have a big head start. I might also mention this kind of equipment is becoming more and more common in the Corn Belt. I think we have 1 or 2 of them in Maryland as well, where the air seeders have been fit to the high boy that would normally be used for spraying. And there are all kinds of other possibilities with technology. This is kind of a cute one that I saw demonstrated. This is a little robot that runs up and down. You just program it, and it broadcasts seed up and down the rows. You know, you don't have to pay it by the hour. It just goes up and down the rows, and it gets a pretty good seed distribution.
So this is some of the data from our trial looking at flown versus drilled cover crops and irrigated versus not irrigated. And so the 2 bars on the left were drilled after the corn grain harvest in October, whereas if that cover crop was flown on, we were able to get it flown on a month earlier in early September. But you can see that really the best cover crop stand, which had the most pounds of nitrogen per acre taken up, was when it was both flown on and irrigated. So especially to ensure a better stand and to reduce the variability, you may have a good stand if it's just flown on, if you get a good rain right afterwards, but to ensure that if you have the equipment, irrigating is best.
So if MDA is listening, it might make sense to incentivize people to run the irrigation. This was 1/3 of an inch of water applied twice, day after and a couple days later. So that's all it took to assure that you got your money's worth out of the cover crop seeding. Want to talk about this one, Sarah?
Sure. So this is some of the deep soil cores on those same farms where we had set up the cover crop trials. We took deep soil cores in November and then again in April. And this is the data from the farm that I showed earlier from Lancaster, PA, that had taken up about 150 pounds of nitrogen per acre. And the graph on the left shows the results from our deep cores that we took in November. And you can see that all the cover crop treatments, the radish, the triticale, and the mix had significantly less nitrogen in the soil profile. This is nitrate nitrogen all the way down to about 2 meters deep from the surface all the way down. It had significantly less nitrate than the plots where there was no cover crop planted. And then from the data from the deep soil cores that we took in April, which is the data on the right, you can see that the radish cover crop released that nitrate by April, and it would be available to be taken up by the following summer crop, whereas the triticale cover crop did not have that surface nitrate available. So that farmer would probably have to apply more nitrogen fertilizer after the triticale. But then the radish and the triticale both cleaned up the deeper soil profile and had less nitrate deeper in the soil than the plots that had no cover crop planted.
So more on this, the downsides of capturing nitrogen with a cover crop that doesn't release it, put it that way. We see this all the time. This is Sidedress time corn in Howard County. This is the actual dry matter weights of this corn with no cover crop, after the radish cover crop, and after the rye cover crop. And you can see the pictures here. Now these were all there was no planting time nitrogen put down here so that we could see this effect. But the result of this, to avoid this, what farmers have to do is have to put down extra nitrogen where they've been using rye or triticale or barley as a cover crop, because they know they're going to get these kinds of effects if they don't. And this is pretty consistent. This is the average of 6 farms where we did this. And again, where we had a cereal, whether that was rye or triticale or other cereals, we got a yield drag. This is the corn weight per corn plant at the V5 stage. And where we had the radish, we got a little bit of a boost. And then the mixtures seem to overcome, putting a little bit of clover and radish mixed in with the rye. So you still have in spring, it looks mostly like rye or triticale, but this was enough nitrogen and lowered the carbon nitrogen ratio enough to overcome that immobilization so that you basically didn't have that yield drag. Another aspect that'll be of interest to you nutrient planters out there, you're probably all familiar with PS&T nitrate data in the soil and how taking that nitrate content at the top foot when the corn's a foot tall in June is predictive of what the yields are likely to be. This is that data. This is the nitrate in the top 30 centimeters taken in June. This is the yield that was eventually grown on those plots. These are only zero nitrogen Sidedress plots. So these are the control plots from a number of experiments in Lancaster and Clarksville, so in central Maryland and southeast Pennsylvania. And you can see there were significant cover crop effects. The radishes were always had some of the highest yields and some of the highest nitrates as well. And then the cereal by itself had some of the lowest nitrates and the lowest yields. But this shows that the cover crop effect is largely, at least in this instance, a nitrogen effect. Of course, there are other effects happening as well, water conservation and infiltration and that type of thing. So we don't usually see a yield response, a positive yield response to the cover crops, although national surveys show that on average there are small yield responses rather than yield drags. This was a case where we did. So sometimes that radish benefit carries out through the season. This is a nitrogen response curve using 0, 60, 120, 180 kilograms of nitrogen per hectare. That's roughly the same as pounds per acre. These are the yields of corn. So this is up around 180 bushel corn, so pretty decent corn when enough nitrogen was supplied, but especially after the radish or after the mixes. The rye never really caught up. So you sometimes get that yield drag, and we think that this was mostly due to the nitrogen tie-up. You're not going to see this kind of response all the time, so most of the time we don't see it. So the question I often get is, if the rye is taking up all that nitrogen and keeping it, when am I going to get it back? It must be building soil organic matter. And I don't think we've really looked at that in Maryland, but I did find this study by Kuo and Jellum, and this was done out in Washington State, in the humid part, high rainfall part of Washington State, where they grow corn and soybeans. And this is expressing the corn yields on a relative basis relative to what no cover crop was. So that's the one is the yield for no cover crop. When they used hairy vetch as a cover crop, they always got a yield boost. That makes sense. Fixed nitrogen. Where they planted rye or ryegrass, they tended to get a yield drag. It was down. I mean, this is half the yield. That's 3/4 of the yield. So a significant yield drag. But over time, that yield drag got less and less and less. So after about 6 to 9 years, it looks like they're starting to, that nitrogen immobilized eventually gets released. But it looks like it's a fairly long-term process. This is about the best data that I've seen in the literature on this process. But I think if we do keep at it, we can expect to get nitrogen back. So just to sum up what the main points of our webinar are today, I think you've seen that it's really important from a nitrogen point of view, but also from all the other benefits you're going to get from the cover crop, to plant early. Plant it early, give it some growing degree days in fall. It needs that warm, that time in reasonably warm temperature while the soil is still warm to get down and get the roots deep. If you plant it in the beginning of September, you can get roots to 6 feet deep. And that's going to pull up nitrogen that otherwise is sure enough going to be lost over the winter. There's almost no doubt about it. Now, the other end of the growing season for cover crops is spring. And maybe we'll give another seminar sometime, another webinar on letting it grow in spring, killing it late. If you want to get benefit, if you're going through all the trouble to plant the cover crop, let's get some benefit from it, both short-term and long-term benefits to both the environment and to our bottom line. So that's a topic maybe for another time. Right now, we're just thanking you for listening out there. I hope none of you, or not too many of you, have fallen asleep. And if you're still awake and still standing, we'd be happy to discuss some of your questions, and happy cover cropping.
Thank you so much. It was interesting. I did a lot of my cover crop research in Minnesota. I'm jealous of all the big yields you're seeing here with the warmer climate. All right, so we did have a couple questions from the audience so far. The first one was asking about the Lancaster study. What was harvested from the field before the cover crops?
Tobacco.
Okay, so those were tobacco fields.
Yeah.
Interesting. All right, the next question is...
I think that was an Amish farmer. So actually, was it horse-drawn?
Yeah.
Yeah, that's what I thought. So that was a unique experience.
I also grew up in Lancaster County, so I'm familiar with some of that too.
Yeah.
All right, the next question, is the study based on just corn and soy crops? We are vegetable growers and our last crop comes off in November. So we use spinach, Asian greens, spring onions, etc. as our cover crop. Is that considered an acceptable cover crop?
Okay, interesting question. So vegetable growers actually have a lot more flexibility in some ways than corn soybean growers because they have the potential to stagger their fields and open up cover crop planting windows. On the other hand, they're growing crops for sale at the same season that the cover crops are growing. So this is a bit of a conundrum. So like you said, you're growing spinach during the winter when the cover crops would be growing during the late fall and the early spring. No, the spinach just isn't going to hack it as a cover crop. It has pretty shallow roots, but I can tell you, and that goes for most of the vegetable crops, unless you're planting brassicas. Now, if you're planting radishes are, of course, the best, but even if you're planting turnips or broccoli or something like that, brassicas do tend to have pretty strong and deep roots. So if you plant them in that season, they will bring nitrogen up. But we have done quite a bit of research. I had a graduate student devote her entire project to growing early spring planted vegetables like spinach and lettuce and carrots and things that are planted in, say, March and April, after a pure stand of radish planted early. And this was done either organically or not organically, but we didn't need to use herbicides to control weeds. And we didn't need to use any fertilizer application. There was enough nitrogen, phosphorus, potassium, calcium, boron, you name it, that was dumped out on that soil surface. And the soil surface had so little residue. It had enough residue during the winter to protect it, but by the time planting season rolled around, the residue was so thin that the soils were warming up significantly earlier. So you could go in and plant a week or two earlier than you could on other field, especially if it had a cover crop going on it. These soils were warmer and a little bit drier and more friable. It was actually a very dramatic difference. It was a difference between a really muddy soil in early spring and one that was crumbly. And the response of the early spring cover crops was pretty amazing, especially the spinach. So when you mention spinach, there's some kind of relationship. I don't know what it is, but there's a relationship between spinach and radish. Now, they're both non-mycorrhizal crops, but they're not related to each other. But there's a relationship when they grow, and spinach loves to grow after radish. Now, some of you may have seen this in lamb's quarter, which is a close relative of spinach. And one thing, if you have a radish cover crop, you will encourage the growth of lamb's quarter. But you'll be amazed if you're growing spinach at the kind of yields and early growth that you'll get. Sorry for that long-winded answer, but we just happen to have a lot of information on that.
Well, thank you. The next question that came in, it says, seems radish after soybeans has the best potential to recover or save in for the following year. If planted early, but how early can you plant and not impact bean harvest even with the early group 3?
So that planting early is going to have to involve interseeding of some kind, either with a high boy or aerial seeding. As soon as those leaves start to turn yellow and you start to drop a few leaves, that's the time to seed it because you're going to get increasing light coming down at that point and the plants are going to survive. The radish is not a tall growing plant, especially when you aerial seed it or seed it in that environment. The seeds are pretty far apart and it will spread out along the ground. So I really don't think you're going to get much interference. You're concerned about having green matter in with the soybeans. There's really very little of that if you're planting radish. Some of the grasses may grow more tall. And that could be a problem. But if you've got certainly about a month where you can get it to grow, and it really is not going to do any serious growth until the leaves are all down. But you can pick up quite a bit of nitrogen then and have it released for your following crop.
All right, a couple more have come in. The next one is I grow turf grass and sod. We are planting into a completely bare soil, hard soil. Do you have any special suggestions?
You're growing turf grass sod, so you're taking off a 1/4 inch of soil with it. And this is not on an organic soil. By that I mean a peat type soil, I suppose. It's probably a silt loam or something. Yeah, that's pretty rough on the soil. If you can afford it, it certainly would be beneficial to rotate some of your land into some cover crops that can fix that soil and improve the condition of it. Again, if compaction is an issue, radish is about the best you can do. A good stand of radish, if you plant it, again, early. Radish is a real wimp if you plant it in spring or you plant it too late. But if you can prepare a field for this seeding by planting radish in late August and letting it grow for a couple of months. You don't even have to kill it. It'll kill itself. I think you'll find that you've got a really greatly improved seed bed and infiltration. Thanks.
All right, the next question is interesting. Is the ammonium nitrogen you're founding down deep going to be tied up there? Would there be enough microbes down that deep to convert it to nitrate?
Okay, so that's a good question. The question was that deep ammonia. We've been finding, would you say, Sarah, roughly the same amount of ammonia as nitrogen in the ammonium form as nitrate form. I don't think that represents the same amount of flux, since the ammonia is much less likely to be moving very fast. You don't pull very much of it out in the water. Most of that would be exchangeable. We don't have really nitrogen fixing or ammonium fixing soils. There are some clays out in the Midwest and a few places in Maryland that will hold on to that nitrogen pretty tightly. We're extracting with potassium sulfate, a fairly weak solution of potassium sulfate, so the ammonia we're getting is probably not highly fixed. It's probably plant available. And we do see the ammonia getting cleaned up as well as the nitrate. So it's available to the cover crop, so that's plant available. But it's just not as leachable as the nitrate would be. So it's dollars down there, right? 200 pounds of nitrogen, 400 pounds of nitrogen, depending on where you buy your nitrogen. That's a significant amount of money that you got down there. It's kind of a shame to let it get away.
Definitely. All right, so the last question I have here is, will this be another spring where radish will not die in parts of Maryland?
Okay, well, it isn't. If it isn't dead yet, it's not dead, right? So again, if you planted the radish early, it's probably dead. If you planted it late, those little plants that are high in nitrogen don't die as easily, and they're still alive, but don't sweat it. The radish is a wimp in spring. It's going to produce some flowers. It's going to provide some resources for beneficial insects. It's not going to compete with your crop. I wouldn't even bother with it. It's just a real wimpy crop, not very competitive in springtime. It's easy to kill with a herbicide or with mechanically, either way. A little 2,4-D will do it if you're concerned.
All right, thank you. Looks like we got another question. Would oats be a better option with radish rather than rye or wheat?
The question was whether oats is a better option. Well, oats also has pretty similar characteristics for immobilization. It depends on whether you're talking about winter oats, spring oats, or winter oats. If it's spring oats, they're likely to winter kill, which makes it a nice companion for the radish since you don't have to kill either of them.
Yeah, we had several farms that did that.
Yeah.
The oats and the radish both winter killed.
So that does save you. If you get a good stand, it can save you the burn down. That's kind of another topic for another webinar, is weed management in these systems. But the oats tends to immobilize the nitrogen, pretty similar to the rye. Not quite as bad as the rye, but pretty similar. And it tends to use a lot of water. So so far this is a really dry spring. I would watch out for water use in the profile this year unless we start getting some rain.
All right. I think we'll take just one more question and we'll move on. But the last one is, how do the cover crops addressed in your study compare to the high-end crops of the legume family?
So the question is, how do these cover crops that we've been talking about compare to legumes? So we did include clovers in some of our mixes, and these clovers do almost all their growth in spring. So they do produce quite a bit of nitrogen depending on how long you let them grow. But if you let them grow into late April, early May, you can easily get another 50, 60, 70 pounds of nitrogen per acre from the clover. So the difference between the legumes is that they're actually adding nitrogen to the system from the air. The radish is not adding nitrogen, it's collecting nitrogen from down deep. The clover does very little. The clover never reached any of that deep nitrogen. It's not a good nitrogen capture, but it did not interfere with the nitrogen capture. That was the point we wanted to make. In spring, you want the nitrogen there at the surface. So if you can get another 40, 50 pounds of nitrogen from the clover, kill it late. Maybe plant it green. It's another topic we can talk about later. You can probably really reduce the fertilizer nitrogen you need to put on and therefore reduce the nitrogen that you're putting into the system. I don't know if that answered your question, but...
All right. Well, thank you both so much for coming and giving a webinar. It's been very informative.
Thank you.
Come on time, too.